Hey everyone, this is a continuation of topic number 3, and we are in our 7B notes packet. Alright, so we're just moving on from topic number 3. Topic 3 is a pretty long topic. Before we continue this, we're just going to talk through a couple scenarios, and this is just to get your mind thinking in the way that it needs to work for today's lesson. So we're going to start with this hypothetical scenario, and it is that you have $1 in your wallet. So suppose you have $1 in your wallet and you earn 20 cents. So when you earn 20 cents, it means that you make money. So to figure out how much money you have, you would do $1 plus that 20 cents. This is how we write 20 cents, right? And you end up with 1.20. That's $1.20. And I know that you could do that in your head probably. You could probably do this one in your head as well. So go back to this original scenario. You have $1 in your wallet, and this time you spent 20 cents. So this is you losing money, right? If you spend 20 cents, you start with your original $1, and you subtract 20 cents, and you get 0.80. And that means that you have 80 cents, right? So here's a couple scenarios. The first one says you have $1.05. So remember, you started at $1. So if you started at $1 and now you have $1.05, you have more than what you started with. That means that you earned 5 cents. And to do that, to figure out how to get 105, we would do 1 plus, we have to write 5 cents as a decimal, 0.05, and we get $1.05. All right, this one says that you have 60 cents. So if you have 60 cents and you started with $1, that means that you spent, how much money did you spend if you end up at 60? You spent 40 cents. So to do that math problem, you would do 1 take away 0.40. That's how you write 40 cents, and you end up at 60 cents. Lastly, you have 93 cents. If you have 93 cents, you have less than $1. That means that you spent 7 cents. And to do that math, we would do 1 minus 0.07, and we get 0.93 cents left over. So this idea is going to be really helpful when we move on with our topic 3. So I'm going to a lot of times refer to money when we do these problems. All right, so example 3, this is about Luan. So it says, Luan says that the population of Swag City can be modeled by the function, and he wrote this equation, y equals 22,000 in parentheses 1.045 to the x power. It says x is the number of years since 2017, which means 2017 is our initial or our starting year. All right, so the first thing it says is this function a growth or decay function? And so we just spent to the beginning of topic 3 learning about how to write a growth or a decay function. And one of them in parentheses was 1 plus a number, and one of them in parentheses was 1 take away a number. This is why we did this problem up here to start with. So I want you to look in parentheses and think about our scenario. If we start at 1, if I ended at 1.045, is that more than $1 or less than $1? And this is going to be growth, and the reason is because 1.045 is greater than 1. And that means that I must have used this equation, or Luan must have used this equation to set up his function. All right, it says, what was the population of Swag City in 2017? 2017, remember, was our initial year, our starting year. So basically, this is just asking what is the starting value, and that's this first number, 22,000. Right, that's this number. All right, it says, what decimal rate is Swag City growing or decaying by? So basically, this is asking 1 plus what number equals 1.045. So if you think about money, start with $1, I end up at $1.045. That means that the decimal rate is 0.045. Next it says, can you write this as a percentage? So to do that, we take our decimal point, and you could think about a couple ways. You could do the trick where you move the decimal place 2 units, or you could multiply this by 100, and that'll give you 4.5%. All right. The next problem is an example of decay, and decay can be a little bit trickier. So it says the value of Miss Dawes' car is modeled by, and it gives you an equation, and our equation is y equals 16,800 in parentheses 0.87x, where x is the number of years since 2015, y is the car's value. Is this function a growth or decay function? So again, I have to decide whether to get that number in parentheses, I have to decide whether I used this or this. And 0.87 is less than 1. That means that this must be decay. I must have subtracted from 1. So I'm going to write because 0.87 is less than 1. What was the car's value in 2015? This is just basically asking what is the initial value, and that is right in your equation right here. 16,800. I'll put dollar signs there. And then lastly, what decimal rate is Miss Dawes' car growing or decaying by? So we know it's decay. This is asking essentially this question. I started at $1. Since it's decay, I subtracted something. I ended at this number right here, 0.87. So think about money. If you have 87 cents, how much money did you spend? And the answer is 13 cents. So 0.13. You could put 0.13 if you want. Can you write this as a percentage? Move the decimal place 2 times, and we get 13%. All right, your homework tonight to work on this, to practice, is homework number 5 in the 7B packet.